What is the charge of an atom that contains 30 protons, or positive particles, 30 neutrons, neutral particles, and 32 electrons, negative particles? The problem tells us the charge of an electron is negative 1.6 times 10 to the negative 19 coulombs, and the charge of a proton is positive 1.6 times 10 to the negative 19 coulombs. Notice that the magnitude or the size of each of these is the same. The electron is 1.6 times 10 to the negative 19, and the proton is 1.6 times 10 to the negative 19. The difference is the electron has a negative charge because it's the negatively charged particle, and the proton has a positive charge because it's the positively charged particle. The problem doesn't give us the charge of a neutron because neutrons have zero charge or are neutral. There are two ways that we can solve this problem, and I'll run through both of those. The first way is to calculate the total positive charge and the total negative charge, and then determine what the net charge is. So if we take our total number of protons, 30 protons, times its charge, each proton has a charge of positive 1.6 times 10 to the negative 19th coulombs. When we multiply those together, we will get 4.8 times 10 to the negative 18 coulombs. Then we'll calculate our total negative charge by taking our 32 electrons times the charge of one electron of negative 1.6 times 10 to the negative 19th coulombs. When we multiply that, we get negative 5.12 times 10 to the negative 18th coulombs is our total negative charge. When we add those together to get our net charge, we get a net charge of negative 0.32 times 10 to the negative 18 coulombs. If we move the decimal over one place, we get negative 3.2 times 10 to the negative 19th coulombs, which then that matches our answer for letter C. Now, the other way we could solve this is just simply figure out which particle we have more of. The charge is based on the number of positive and negative charges. Since we have 30 protons or positive charges and 32 electrons or negative charges, we have more negatives than positives. So we just look at what is the net difference. If we take 32 electrons minus 30 protons, we're left with 2 electrons. So if I take 2 electrons times the charge of each electron of negative 1.6 times 10 to the negative 19th power, I do that and I get negative 3.2 times 10 to the negative 19th coulombs, which is the same answer as we got before, which is letter C.